An AI agent had full access to a travel booking platform, a calendar, and a payment method. It was given one task. It ended up booking 2 flights on the same day, in opposite directions, and charged for both. This video is about exactly how that happened, why it is not a freak accident, and what it tells us about the state of AI agents right now. Before we get into the failure, let us be clear about what an AI agent actually is. An AI agent is a language model that has been given tools. Those tools might include searching the web, reading your calendar, or in this case, completing a flight booking on your behalf. The agent breaks a goal into steps, calls tools in sequence, reads the results, and decides what to do next. That loop sounds reliable. It often is not. The task started normally. The user asked the agent to book a round trip from New York to London for a specific week, and to also book a short domestic flight home from a conference happening a day before the international trip departed. 2 bookings, close together in time. That is where the complexity started. Most AI agent frameworks today handle multi-step tasks through what is called a reasoning chain. The agent writes out its plan in text, then executes each step. The problem is that the reasoning chain lives inside a context window. That context window has a size limit. On a complex booking task with multiple tool calls, search results, and confirmation strings, the earlier parts of the plan can fall out of the active context. In this case, by the time the agent was confirming the second booking, the details of the first booking had been partially pushed out of its working memory. The agent no longer had a clear internal representation of what it had already done. It was not lying. It was not malfunctioning in a dramatic sense. It simply did not remember what it had confirmed 20 tool calls earlier. This is called a context management failure, and it is one of the most common problems in production AI agent systems right now. The model is not stupid. It is operating exactly as designed. The design just does not include reliable long-term memory across a complex task unless the developer builds that in explicitly. Many frameworks do not do this by default. The second problem was in the reasoning chain itself. When the agent was deciding how to schedule the domestic flight, it checked the calendar and saw the international departure date. But the way it interpreted that date was off by 1. It treated the international flight as departing on a different day than it actually was because of a time zone offset in the calendar API response that it did not account for. That one-day misread cascaded through every decision that followed. The agent was not checking its work against reality. It was checking its work against its own earlier reasoning, which was already wrong. This is what researchers call compounding errors in chain-of-thought reasoning, and it is a known, documented problem. The agent became increasingly confident in an outcome that was increasingly wrong. There is also a structural issue with how many agent frameworks handle parallel tool calls. When an agent sends out 2 booking requests close together, especially in frameworks that allow concurrent execution, there is often no built-in check that asks, do these 2 actions conflict with each other? The conflict detection has to be written by the developer. If it is not there, the agent will complete both actions and report success on both. The booking platform APIs involved here also deserve mention. Most travel booking APIs will confirm a purchase if the payment clears. They do not check whether you already have a conflicting flight booked through the same or a different service. That is a known gap in the ecosystem. The API does its one job. The intelligence layer is supposed to catch the conflict. In this case, it did not. So now there are 2 confirmed bookings. The agent reports success. The user gets 2 confirmation emails. The conflict is only caught by the human, manually, after the fact. At this point, one of the tickets is refundable and one is not. The resolution costs several hours and a change fee. Not catastrophic. But a real cost from an automated system that was supposed to save time. There were at least 3 points in this process where a guardrail could have stopped the mistake. The first was a pre-confirmation check, where the agent pauses before any financial transaction and summarizes what it is about to do, then waits for human approval. This is called a human-in-the-loop checkpoint. It is not glamorous, but it works. The second guardrail would have been a calendar conflict check, built directly into the agent's workflow as a required step before any booking is finalized. Not optional. Not something the agent decides to do based on its reasoning. A hard-coded rule that runs every time. This is the difference between soft guidance in a system prompt and hard constraints in the tool execution layer. The third guardrail was persistent memory. If the agent had written each confirmed booking to a short structured log and read that log at the start of every new booking step, it would have had a reliable record of what was already done. A few lines of structured data would have been enough. The information was available. Nobody told the agent to store it and check it. If you still want to use AI agents for travel or scheduling tasks, here is what a safer setup looks like. First, always require explicit human confirmation before any financial transaction. Second, build conflict detection as a tool the agent must call, not a behavior you hope the agent exhibits. Third, use an agent framework that supports persistent memory, or build a simple state file the agent reads and writes throughout the task. It is also worth thinking carefully about what tasks you give agents full autonomy over. Reading, summarizing, drafting, researching, these are low risk. Booking, purchasing, sending emails on your behalf, deleting files, these carry real consequences if the agent is wrong. The cost of a human checkpoint is usually seconds. The cost of skipping it can be much higher. The AI agent industry is moving fast, and the frameworks are improving. OpenAI, Anthropic, Google, and a wave of open-source projects are all working on better memory systems, better tool orchestration, and more reliable reasoning. But right now, in 2025, these systems still make mistakes that a focused human would not make. Understanding why is the first step to using them responsibly. The story here is not that AI agents are bad or that you should avoid them. The story is that they are powerful, partially reliable, and often deployed without the safety layers that the underlying technology actually needs. Knowing where the gaps are puts you in a much better position than most users who are handing these systems real access and assuming everything will work out. If this breakdown was useful, hit the like button. It genuinely helps this channel reach more people who want honest, specific content about AI. Subscribe if you want to keep up with how AI agents are evolving, where they are still falling short, and how to build or use them more effectively. Next, we are going deep on how to set up a human-in-the-loop agent workflow from scratch, so you can get the benefits of automation without the surprises. That video is coming up next.